Okay, illustrative math, unit 2, lesson 25 is called summing up. When I say sum, I mean addition. All right, so goal, I can calculate the sums of the terms in a geometric sequence by using a formula. So geometric sequence, been a while since you've done that, but I'm going to give you a geometric sequence here. All right, so my common ratio is 3 because you're multiplying by 3. So I'll call R 3, that's my common ratio. Your first term is equal to this 3 right here. But instead of saying A1, I'm just going to call it A. A for initial amount. If I wanted to add up, like, let's say the sum of the first, I don't know, 8 terms, you could count out 8 terms and add them all up. You could do it. But what if I said the sum of the first 30 terms? Now it starts to get a little bit more tedious because you got to count out 30 terms. You got to add them up. So if I told you that there's a formula here to do that for me, all you need to know is your common ratio, the first term, and then the number of terms. So we'll say n would be 30. That'd be the number of terms. You could plug all that info in and find the total sum. Kind of useful. All right, so what do you notice? What do you wonder? So start out here with 0. First one is 0 triangles added, total number of triangles added. So on this one, I'm going to add 1, 2, 3 there. The next one, I'm adding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the first one you added 3, and then we added 12, which comes out to be 3 times 4. And then I go on. Third one, I have the first 3 that I added, the next 12, which was 3 times 4. And then what's going to happen is you're going to have to multiply it by 4 again. So you're summing, because you're adding them all up, 3 times 4 times 4. And then, I'm going to skip. I'll go down to the fourth one before we look at the end. It's going to be everything's the same. 3 times 4. And you're adding them all together. 3 times 4 squared. 3 times 4 cubed. And what you should notice here is this number and this number here are always going to be, your last power is going to be 1 less. This is to the first, okay? So when I look at n, you start at 3, and then you add 3 times 4 plus 3 times 4 squared. And then I put a gap there because I don't know how many I'm going to add, but I know that if I'm going to n, my power is going to be 1 less than n. So that's n minus 1. Okay. All right. So this basically is saying that a equals 3 is our initial term. And if you look back at your table when I started at term 1, we're not going to use term 0. They really shouldn't have given us this. But term 1 is 3. That's like our A1 with our geometric sequence, okay? So think of that as A1 equals 3. So on here, we're going to call it A equals 3. And then R is your common ratio. It's like you're multiplying by 4. Because if you look here, I added how many total triangles? I added 12 more. So it was really like, it's like I took my first term was 3. And then my next term was 12. It's like I times it by 4. And then the third one, it's almost like I'm multiplying by 4 again. I get the 48. Okay. So that's where it comes from. So 4 is your common ratio. Okay. So if I wanted to add them all up, you start with 3, 3 times 4, 3 times, you're going to have 2 4s, and then all the way up, your final number of 4s is going to be 1 less than the term number. So what they did was, instead of saying 4 and 3, we replaced the 3 with an A. So I basically just took this 3 right here and changed all my 3s to A's. So it's a little bit more general, less specific for the problem. And I took all my 4s and replaced them with R. Okay, everything else stayed the same. And S is the sum. Okay. And then if I factored out an A, I could now have it in this form. So these are the same. This gets us to here because this is real specific. This is more general. And then this, I factor out an A. It's nice and neat. It's factored there. Okay, so there's that. All right, so this is where I was left with. If you look back here, I had S equals A times 1 plus R squared plus all the way up R to the n minus 1. So same formula. What would happen if I multiplied each side by 1 minus R? And then they give you a hint there as well. So if you want to pause the video and try to figure it out on your own, awesome. If not, I'll walk you through it here. So what you're going to do is you're going to take x minus 1, whoops, times s equals a x minus 1 times 1 plus r squared dot 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 r to the n minus 1. So what I'm going to do is I'm going to try to multiply these two. Now you might say, how can you do that with this gap here? What you're going to see here, oh shoot, you know what, I shouldn't have used x, I should have used r, sorry. I looked at this x minus 1, it should have been r minus 1, there we go. I'm going to see if I can do this here. Oh, geez, I'm still wrong. Oh my gosh, I'm so silly. It's 1 minus r. All right, there we go. Sorry. There we go. All right. We're going to go all the way up to the r to the n minus 1. All right. So I start multiplying 1 times 1. This will be negative r. This will be positive r. This will be negative r squared. Positive r squared. Negative r cubed. R cubed. And what you start to see is these cancel out diagonally. So the only two terms that are going to matter are going to be this one and this one. So what's this? This is going to be negative r times r to the n minus 1. So could I simplify that a little bit? Negative r times positive r is going to still be a negative r. And then since they have the same base, you can add the power. So it's 1 plus n minus 1. Those cancel. So it's negative r to the n that goes right here. So this whole thing, if I multiply these two, it's going to end up giving me 1 minus r to the n. So I end up here, and then it tells me to rewrite it so that it's s equals. So all I got to do here is divide by 1 minus r, and that'll get s equals a times 1 minus r to the n all over 1 minus r. So use this new formula to calculate how many triangles after the original are in the first 5, 10, and 15 with the snowflake example. So I go back here, here's my snowflake. And remember, we're finding the sum. We're not just finding the term number. So my initial value A is still going to be 3. For this one, n equals 5. And my common ratio is 4 because we're multiplying by 4. So I'm going to plug them in. 3 times 1 minus 4 to the 5th over 1 minus 4. All right, so I'm going to type that into my calculator. And I get What do I get here? Whoops, hold on, I typed it in wrong. There we go. You get 1,023. So that's how many triangles you've added total since the first step. The next one would be everything stays the same. My first term, my common ratio, I would just have to change the 5 to a 10. And that'll give me the total sum. So I get 1,048,575. And then the last one, same thing, just change it to a 15. And it starts to get pretty big. So you get 1,073,741,823. So these would be your other answers there. That's how many total triangles you've added. All right, so let's take a look at this one. Han is prescribed a course of antibiotics for an infection. He's told to take a 150 milligram dose of the antibiotic regularly every 12 hours for 15 days. Han is curious about the antibiotic and learns that at the end of the 12 hours, only 5% of the dose is still in his body. How much of the antibiotic is in the body after the first, second, and third doses? Okay. So, hang on one second. Okay, so 150 on the first dose, but then the second dose. So there's out of the first dose, there's only 5% left. So if I took 0.05 times 150 from that first dose, how much is that? That's 7.5. So it's like 7.5 from the original, but then he took the next dose, so it's 150. So it's 157.5. And then he goes to the third dose. Well, he had 7.5 remaining from the, well, let's just say 5% of that that's still in his body is remaining 12 hours later. So if I took the 157.5 times that by 0.05, and then you add the extra 150 because he takes another dose. Let's do that. We end up with 157.875. Okay, so there's first, second, third dose. When will the total amount of the antibiotic in Han be highest over the course of the 15-day treatment? So 15 days, if he does it every 12 hours, that's twice a day. We need to find his 30th term. So A of 30, basically, or the sum of the first, really you're adding them all together. So let's see if I can use this formula here. So our initial value is 150. So we go back to that formula, S equals A times 1 minus R to the N over 1 minus R. So 150, 1 minus, my rate is 0.05 to the N power, divided by 1 minus 0.05. So I plug that all in, and that'll give me the sum. So that is going to end up being 157.8947. All right, so what would you need to figure out, do to figure out the first 30 terms of the sequence? So your first term you need is 3 over 10. we need to figure out what your common ratio is. So it looks like I'm multiplying by 1/10 because the 3 stays the same. So that's a 1, and then the 10 is 10 times bigger. So you could do 1/10, or I guess it might be easier to plug it into your calculator as 0.1. If I wanted to make it a decimal, I probably could. Might be easier to type into your calculator. And we would need to know the number of terms we're adding together, so that would be n is 30. So first term, 1 minus r to the n over 1 minus r. That will add up. Instead of putting commas there, it's almost like I have plus signs all the way up to the 30th term. So go ahead, let's type that into our calculator, and let's see what we get here. 0.3 times . And I got 1/3. All right, so you might say, how can it be an exact fraction like that if you're always adding? Well, it just gets so close to 1/3 that it's pretty much exact. All right, so basically I understand why the geometric sum formula, so we kind of like derived it there. Make sure you know this formula. Make sure you know all these numbers here. If you need to pause the video and write that down, go for it. Last one, same formula. A drug is prescribed to take for a patient to take 200 milligrams every 12 hours for 10 days. After 12 hours, 4% of the dose is still in the body. How much of the drug is in the body right after the last dose? So initial value is 200. 1 minus 0.04 to the, let's see here, for 10 days. So 12 hours, that's twice a day. So that would be 20 doses, would give me 10 days. Okay. So go ahead, type that into your calculator. You should get approximately, I had to round, 208.33 milligrams. Okay. Hope you enjoyed this video. Thank you for watching.